This is a very important video where we are going to find for the given triangle area, circumradius and Inradius. These three things are not easy to find, and you'll also learn a very important relation which is connecting incenter with area and semi-perimeter. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll select very important questions based on triangle challenge. We are given an isosceles triangle ABC where AB equals to AC equals to 10 centimeters and BC is 12 centimeters. Diagram is given to you. You need to find area of the triangle ABC, find circumradius of the triangle ABC, and find Inradius of the triangle ABC. Now these are very important parts of triangle, finding area, circumradius, and Inradius of any triangle. Well, this is a special triangle since we have two sides equal, an isosceles triangle, AB and AC being 10, AB and AC being 10, and BC is 12 centimeters. You can always pause the video, answer the question. Now, let's try to understand each one of them, and then we will solve. To find the area of the triangle, we'll have to drop the perpendicular, right? And let us say this point is D. In that case, area is going to be what? So area is going to be half base, which is BC, times height, which is AD, right? Now, how do you figure out the circumradius? Now, to find the circumradius, circumradius is a point from where all the vertices are same distance away, right? So you basically find circumradius by a point of intersection where the right bisectors intersect, right? And you know the circumcenter will be a point which is same distance. So point somewhere, let us see, right? Kind of like this. So this point, let me call this as O, will be the circumcenter of this particular. This is what you need to find. So let's say R is the radius. So we need to find the circumradius, which is R in this case. And thirdly, we want to find Inradius. Inradius is a point where the bisectors of the angle intersect, right? Perfect. So if there is a point which is incenter, in that case, the bisector of the angles will intersect, right? So I hope the basic concept is clear. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are right there on top of their class getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us solve these questions one by one. So the very first one is to find the area of this triangle ABC. So area is half base into height. To find the height, we can drop a perpendicular from A to BC. Since it is an isosceles triangle, the perpendicular will divide BC into two equal parts, and therefore this point, which I can label as D, will be the midpoint, correct? Since it is a midpoint, each side B to D and D to C will be 6 centimeters long. So we can find AD using Pythagorean theorem, right? So AD is 10 square minus 6 square square root. That is 100 minus 36 square root, which is 64, and is equal to 8, right? So it is a Pythagorean triple, as you know. And so this A to D is 8 centimeters. And now it is easy to find area. So area will be half of base, which is BC, right? Times AD, the altitude, which in this case is half of BC is 12, times 8, right? So 6 times 8, we get area as 48 unit square, which is centimeter square in this particular case, correct? 6 times 8, 48 centimeters square is the area of this particular triangle. Perfect. Now let's move on to find the circumcenter of this particular triangle. So circumradius basically we need to find. As we discussed earlier, circumradius is a point, same distance from the vertices, right? So that is the kind of point which we're looking for, correct? It is same distance from all the three vertices. So let's call this distance as R, the radius, because same distance means you can make a circle with this radius where the 3 points which we are talking about will be on this particular circle. Get the idea, right? That is the circumcenter. Now how do we find R? Now clearly each line is the right bisector, right? So circumcenter is on right bisectors. So if I draw the right bisector, it will be the same point D, right? As we did earlier, because that is 90 degrees and it bisects. And similarly, this will be bisecting the other two sides. So we have seen earlier that this midpoint, 12 centimeter half, will be 6, and the total length A to D is 8, right? We need to find capital R. This is also R, right? Because it is same distance. So you can see that R basically is equal to 8 minus something, right? Which we don't know. So we can say this height. So total height in this particular case is 8, right? So this area, let's call this point as O here. Then O to D will be how much? O to D is going to be 8 minus R, correct? 8 minus R, right? And now we have to see that this particular triangle, which is ODB, the angle at D is 90, so ODB is a right triangle. So we can apply the Pythagorean theorem and find a relation between BO, OD and BD, right? So we have BD square plus OD square is equal to BO square, right? So we have our equation. BD is 6, so 6 square plus O to D is 8 minus R square and BO is R square. So we have this quadratic equation from which we can find the value of R, correct? Perfect. So we can extend this 36 plus 8 minus R whole square gives you 8 square, which is 64, minus 2AB, which is 16R, plus we get R square equals to R square, right? So taking this R square on the right hand side, it gets cancelled, so we can find what 16R is, correct? So we have 16R is equal to 36 plus 64, right? 36 plus 64 is 100. So we can write this as 100 minus 16R equals to 0, right? Taking R square to the other side, it gets cancelled. So 16R is equal to 100 and therefore R is equal to 100 over 16, correct? Dividing by 4, we get 25 over 4. So that becomes the value of R, right? 25 by 4 centimeters in this particular case. So therefore, our answer is that circumradius is equal to 25 by 4 centimeters. Perfect. So you see, we applied the information that So I hope these steps are so I hope these steps are absolutely clear. So we have our value for circumradius. Now perfect. So now let us take up the third part, which is finding Inradius. Now Inradius is the point in the circle which is the intersection of right bisectors of the angles, right? How do you get that point? So this is a point where the angle bisectors intersect, right? Now to get this point, we can use another strategy, and that is that Inradius is related with the area of triangle, correct? So you know that area of triangle is equal to Inradius times the semi-perimeter. Since we know all the sides, we know what semi-perimeter is, right? Semi-perimeter in this case is 10 plus 10 plus 12 divided by 2. Which is 32 by 2 or 16. We already found the area of triangle in part 1, half base into height, which was 48. And therefore, Inradius will be what? Inradius will be area of the triangle divided by S, the semi-perimeter. So it is 48 over 16, and that gives us a value of 3, sorry. 48 by 16 is 3. Okay? So we get Inradius as 3 centimeters. Perfect. So that is how we can actually find Inradius. So what you learn in this is very important relations, especially the Inradius relation, right? So remember this, that Inradius can be found using the ratio of area of triangle to semi-perimeter. So with that, we end our video. I hope you understand the strategy to find all the three things, which is area, circumradius, and inradius for a given isosceles triangle. Perfect. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.